Hari Om. In our previous video, we have discussed what is an object-oriented design and the very basic concepts of object-oriented design. In which, in this video, we are going to discuss what are the different terminologies that are used in the object-oriented design. The different terminologies that are used in the object-oriented design. And most of these terms you are already familiar with because you have studied object-oriented programming languages like C++, Java, and also C# programming language. So in all these three programming languages, you have already come across what is an object, what is an abstraction, what is class, what is an attribute, what are the different operations, what do you mean by inheritance, polymorphism, encapsulation, hierarchy, messages. All these terms we are already familiar with. So in this video, we are going to just touch upon, we just browse through these terms. I'm going to just describe these terms, and when we meet in the Google Meet or when we join using any of the tools like Zoom or Google Meet, we can discuss them in detail if you have any doubts. So these are the different terminologies that will be related to the object-oriented design. So the very first term is what you call as an object, which we have already discussed what is an object. So an object in the context of object-oriented design is nothing but an entity which is able to save a state information, and this entity can offer a number of operations to either examine or affect the state. And not only that, because of this, I can call an object is characterized by number of operations and a state which remembers the effect of these operations. This is a very simple definition I can give for an object, which we have already discussed. Let us see what is a message in the object-oriented design concept. So conceptually, the objects communicate by message passing. So messages will be passed between the objects for the communication purpose. So the messages will consist of the identity of the target object to whom you want to communicate and the name of the requested operation. So when you communicate to another object, obviously you want to perform some kind of operation. So you have to specify what is the name of the requested operation and any other operation needed to perform the function. Any other operation needed to perform the function. So these are the three things that will be available in a message. So what are the three things? A message will consist of what is the target object and what is the name of the requested operation, and not only that, any other operation needed to perform this particular operation. So suppose say object A wants to communicate with object B. So object A must pass a message to object B saying that the message will consist of three information. What are the three information? The target object. Which is the target object? B is the target object. So specify B. You want to communicate to B. Now suppose say you want object B to calculate the percentage of the student marks. So you have to specify you want to calculate the percentage of the student. So that is what you call as name of the requested operation, calculate percentage. Then any other operation needed to perform the requested operation. What is the requested operation? You want to calculate the percentage. What is the other operation needed to perform the percentage calculation? I have to find out the total of the marks. Only then I can find out the percentage calculation. So one message if you want to send, you have to specify the target object. Then you have to specify the requested operation, something like calculate percentage, and you have to specify other operation. What is the other operation? The other operation is calculate the total. So this is how one message will contain the information of the target object, the requested operation, and any other operation needed to perform the function. Okay. And when you have these kinds of messages, especially in the distributed systems, the object communications will be implemented as a text message. The object communication will be implemented as text message, and the objects will be exchanging the text messages. The receiving object will be parsing the message, and it will identify what is the service to be done and the associated data, and it carries out the requested service. And these messages will be implemented as procedure or function calls. So what it says, whenever you are passing the message, especially in the distributed system, and the objects communications will be implemented directly as text messages, and these text messages will be exchanged between the objects, and the receiving object will be parsing. When I say parsing, it will scan the message, and when it scans the message, it can identify to whom the request is coming in, and what is the kind of service requested, and what are the associated data for that particular service, and it will carry out the requested service. And these messages will be generally implemented as procedure or function calls. So this is what you have to understand about the message. So message is nothing but how the communication between the objects is carried out. And the third term you have to know in the object-oriented design is abstraction. So in object-oriented design, the complexity of the problem domain is generally managed using the abstraction. So abstraction is nothing but it is the elimination of irrelevant and the amplification of the essentials. That is what you call as an abstraction. Abstraction is the elimination of the irrelevant and the amplification of the essential. So whatever is irrelevant, that will be removed, and whatever is essential, that will be detailed, or it will be amplified. So say for example, when you are having problems, all the problems will be having different levels of abstraction. Say for example, if you have a car as the high level abstraction for driving, then the mechanics need to work at a lower level of abstraction. So they do care about details and need to know about the batteries and engines. So in the higher level of abstraction, you specify the car, and in the lower level of abstraction, you will specify the mechanics, and the mechanics need to understand about the engines, batteries, or the kind of services that are to be provided to the car. So that is how we will be specifying the abstraction. So abstraction, you can say it is generally a generalizing process. You call it as generalizing process. The ideas and the concepts and all the logics, everything can be generalized using the abstraction. So the details that you are going to give to the abstraction will be generally used for the communication process, for the definition process. So as I said, it is the elimination of the irrelevant information, and it is the amplification of the essentials. What is important for that particular object to be defined will be specified in the abstraction. So that is why we say the classes are nothing but the abstraction of the objects. Now the next term that you should know is a class. A class is nothing but, in any system, already you might have come across classes definition in your object oriented programming languages. So here in any system, you will have number of objects. Number of objects will be existing in any system, and these objects will have some common characteristics. So if I am going to have 100 students, these students will have some common characteristics. and the group these objects according to these characteristics, and this type of grouping is what you call as a class. So when you have number of objects like students, teachers, accounts, office, non-teaching staff, like that, if you have different objects, and these objects must be grouped together based on the characteristics. So the characteristics of the students will be same, characteristics of the teacher will be same, characteristics of the non-teaching staff will be same. So what you can do, you can group these objects and you can call them as a class. So non-teaching staff becomes one classification, teachers become another classification, students become another classification. So hence a class is known as a set of objects which share a common structure and a common behavior. And for any class, the instance of that particular class becomes an object. An instance of that particular class becomes an object, and generally the classes will act as a blueprint for the objects. So it acts as a skeleton for the objects, I can say, or I can say it is a blueprint of the objects, I can say, or it is the design structure of a object, I can say, or I can say it is an abstraction for the set of objects. So this is the term that we are already familiar with. Now the next term is what you call as an attribute. It is called as an attribute. Attribute is nothing but the characteristics of a particular object is defined as an attribute. So an attribute will be a data value held by the object in a class, and each attribute will have a value for each object instance. So say for example, if you define a class called a student, then for this class you will have an attribute saying that student name, student roll number, student percentage, student's rank, student total, like that you will have different attributes. So for each instance of that particular object you will have a value. Okay, for example, if you have a class called a square, then the class called a square will have two attributes, say the color as well as the array of points, or you can say area of the square and the side of the square, like that. Whatever characteristics you want to give for that particular object, that can be represented as an attribute. Then apart from attributes, each object will have its own functions also, which you call as the operations. So an operation is a function or transformation that may be applied to or by objects in a particular class. So it will be applied to an object or it will be applied by the object. So these are the operations. But say for example, if I say addition of two matrices, then it becomes a function which is applied to that particular object. If I say calculate the percentage, it will be an operation which will be applied by that particular object. So all the objects in a class will share same operation, and an object knows its class, and hence the right implementation of the operation is also known. Now the next important term that you have to come across is what you call as inheritance. So inheritance is nothing but inheriting the qualities of one class to another class, which you are already familiar with. So there will be different levels in the inheritance also. The low level classes are called as subclasses or the derived classes, and it will be inheriting the state of a class, and it will also inherit the behavior of a particular class. And these low level classes will inherit the state and behavior from the high level classes, which you call as the superclass or the base class. So all these terms you are already familiar with. When you have studied your object-oriented programming language. Then polymorphism is another very important concept that comes in the object-oriented design. So polymorphism, when we abstract just the interface of an operation and leave the implementation to subclasses, it is called as polymorphic operation. So this process is what you call as polymorphism. That is, I repeat, when we abstract just the interface of an operation and leave the implementation to subclasses, then it is called as polymorphic operation. So here you can just recall the concepts that we studied in C# programming language under the topic inheritance, where we have discussed polymorphism. So when you have overriding, when you have function overriding or method overriding, we call it as polymorphism, where base class is having some kind of abstraction which is to be implemented in the derived class. That is what you call as function overriding. Base class is having one specification, you want to implement it in the derived class in a different way. That you call as a polymorphic operation, which is known as the polymorphism. So this is just a definition given. So you can have different types of polymorphism, all those things we discussed in the object-oriented programming language. But when you talk about the object-oriented design approach for the polymorphism, it is only from the higher level classes, you take the information and implement it in the lower level classes. Then you call it as polymorphism. And another important concept that comes in the object-oriented design is your encapsulation. So encapsulation is nothing but information hiding, and it is also commonly referred as information hiding. So here it consists of the separation of the external aspects of an object from the internal implementation details of the object. I repeat, encapsulation is nothing but it consists of the separation, or it deals with the separation of the external aspects of an object from the internal implementation. So external will be shown to the user, and the user will not have an idea of how it is being implemented. So the implementation details is completely hidden from the user. Now when you take this encapsulation, the external aspects of an object are accessible by the other objects through the methods, whereas the internal implementation of these methods will be hidden from the external objects. So from the external aspects of the objects, so you can access an object using the method. This is what you call as external aspects of an object, which is accessible by other objects. How do you access it? Through different methods that are available for the object. Whereas the internal implementation, how this process is being done, that is not shown here, which will be hidden from the external objects sending the message. This is what you call as the encapsulation. Therefore, it is possible to change the implementation without updating the clients as long as the interface is unchanged, and the clients will not be affected by the changes in the implementation. And not only that, the encapsulation deals with permitting or restricting a client class ability to modify the attributes or invoking the methods. So using the encapsulation, you can specify that this is a private object which you can, this is a private attribute which you cannot touch upon. This is a public attribute which you can modify. This is a public method which you can access. All those things you can have in the encapsulation concept. Now the next important concept that comes in the object-oriented design terminology is what you call as hierarchy. Hierarchy involves organizing something according to some particular order or rank. For example, the complexity, responsibility, etc. So this is another mechanism for reducing the complexity of the software. How? Because when you have a large and complex problem, you will start decomposing it. So whenever you decompose a particular object or a particular concept, obviously you will have next level in that particular decomposition. So when you have different levels, in the decomposition, obviously you are going to have an hierarchy. So your hierarchy is nothing but a mechanism for reducing the complexity of the software by being able to treat and express subtypes in a generic way. So you have a major task, and the major task will be decomposed into smaller tasks. Again, the smaller task can be decomposed into atomic tasks. So until you get a single unit, you can keep on decomposing it. So when you have decomposition, many levels of decomposition, obviously the hierarchy concept comes there. So in summary, you can say with object-oriented design, we use abstraction to break a problem into manageable chunks. So major problem will be broken into smaller problems, which you call as smaller manageable chunks. Then we can comprehend the problem as a whole or study parts of the problem at lower level of abstraction. So if you are going to work at the appropriate level of abstraction, then any problem we find can be solved relatively easy. So that is why the large and complex problem, if you are going to, when you have a large and complex problem, the highest level will be having abstraction, right? So you will have a very vague idea, just the skeleton or the blueprint will be available. You start adding the details slowly and you start decomposing them, then any problem will be solved relatively easy using the different levels of abstraction. So you have to work at the right level of abstraction. So if you don't work at the right level of abstraction, then the whole problem decomposition will be a erroneous one. So what you have to do, at what level you have to decompose, you have to analyze, and why you are decomposing it, you have to understand. Then how it can be decomposed. These are the things that you have to understand. At what level you want to do the decomposition, and why you are doing the decomposition, and how the decomposition is to be done. So these are the different things that you have to take care. So we have discussed in this video, we have discussed what are the different terms related to the object oriented design. We have seen what is an object. We have seen what is a message. So message is nothing but when the objects wants to communicate between each other, they will be communicating by passing the messages. The message will contain to whom it has to communicate, which you call as the target object, and for what it is communicating. So some kind of service it wants, that is what it will be specified as the requested operation. Then if you want to get your service, some other related services should also be done. That is what you call as other operation needed to perform the function. Then what is an abstraction? We have seen any idea which is being generalized by eliminating the irrelevant information and amplifying the essentials is what you call as an abstraction. So whenever you have the complexity, it can be managed using the abstraction. And we have seen what is a class. So class is nothing but group of objects according to the characteristics. Common characteristics is what you call as a class, and instance of that particular class becomes an object. So generally a blueprint for the object collection is what you call as a class. Then attribute is nothing but one of the characteristics of the object will be specified as an attribute, which will contain a data value. Then operation is nothing but a function or a transformation which will be applied on the object or which will be applied by the object is what you call as an operation. Then we have seen three important object oriented properties. You call it as inheritance, polymorphism and encapsulation. Inheritance is nothing but a low level class will inherit the states and behavior of the high level class. Polymorphism is nothing but whenever you want to have just the abstraction and the subclasses will be implementing the abstraction is what you call as polymorphism. Then you have encapsulation, which is nothing but hiding the information. So the external aspects and the internal implementation will be separated, which you call as the encapsulation. Then you have a last term which you call as the hierarchy. So it involves organizing something according to some particular order or ranking. So what you do, a larger problem will be decomposed. So when you start decomposing, obviously it will have different levels which you call as the hierarchy. But when you decompose, the thing that you have to understand here is at what level you have to decompose, why you are decomposing, and how the decomposition is to be carried out. So these are the things we have to understand as the terminologies used in the object-oriented design. So in the next video, we will be talking about what are the different steps to analyze and design the object-oriented system. So these are the different steps that we will be discussing to analyze and design the object-oriented system. So if you have a complex problem and you have decided this is a real-time problem for which you need an object-oriented approach, then you have to follow these different steps to analyze and design the system which is using the object-oriented approach. So you have to create a model, use case model, then you have to draw the activity diagram, then you have to draw the interaction diagram, then you have to draw the class diagram, then you need to have the state chart and the object diagram, then you have to draw the component and deployment diagram, then you have to derive the design document. So from the problem statement, you will have the design document if you follow all these steps in the order. So we will discuss what are these steps in detail in the next video. Thank you.